Every year, hundreds of people die in India because of gas cylinder blasts, especially when the cylinders are leaking. Today we are going to see how we can use simple circuitry to make a device which can detect these gas leaks. The heart of the circuit is this gas detector module, which can detect gases like butane, natural gas, also known as LPG. The module is readily available in Amazon for under 300 rupees, and this basically is designed to work with Arduino modules only. But today we are going to see how we can use this with a simple circuit to use without Arduino module. Coming to the specifications of this module, there are 4 pins. One is VCC, which is the positive rail, next is ground, and then comes the digital output and analog output. Today we are going to use only analog output to drive our circuit. And also there's a potentiometer on this module, as you can see, which can be used to control the sensitivity of the module. We need a buzzer which can alarm us when there is a gas leak, so we can use a small buzzer like this one, which can operate any voltage between 5 volts to 12 volts, or we can make one of our own. And I prefer to make a buzzer of my own using a 555 timer IC and using speaker and few more components. And I chose to design my own circuit because I can vary the sound of this buzzer depending on my need. For example, I chose here a little higher pitch sound so that it can be heard all over my house when there is a gas leak. First I started by connecting positive and negative rails to the 8th pin and the first pin of the IC. Then I connected a 0.022 microfarad capacitor between first pin and the second pin. I then connected a wire between the 6th pin and the second pin. I'm simply constructing an unstable oscillator here, which can produce a frequency of audible range. I connected the speaker between the 3rd pin, which is the output pin, and the ground. I connected a 7.8K resistor between 8th pin and the 7th pin, and also a 5.6K resistor between the 7th pin and the 6th pin. At this stage, if you give power to the circuit, it should produce a very high-pitched sound, like this. If it doesn't work at this stage, try connecting a wire from the 4th pin to 8th pin, that is VCC. Next, I'll proceed by connecting a 330 ohm resistor from the 4th pin to the ground. This will keep the circuit switched off unless there is a voltage applied at the 4th pin. Next comes our gas sensor module. I'll connect the gas sensor module onto the breadboard and give the VCC and ground wires. Next I connect a BC547 transistor onto the breadboard. The analog output of the gas sensor will be connected to the base of this transistor to drive this transistor on and off. The collector of this transistor will be directly connected to the VCC, that is 5 volts. And the emitter of the transistor is connected to the 4th pin of the 555 timer IC. Now the circuit is complete. Let's switch this on and see if that works. As you can see, as soon as I switch it on, there is a red color LED glowing on this board indicating that it's switched on. Now to test it, just light a common cooking lighter and blow the flame. Only the gas is released and the flame is not on. And once I bring it close, as you can see, the second light is switched on and the buzzer starts ringing, like this. Now the circuit is working. You can also connect one more transistor with collector and base connected to the existing transistor, and the emitter can be connected to a set of LEDs so that whenever there is a gas leak detected, the LEDs also will switch on, indicating that there is a gas leak, like this. Once tested completely, I soldered the whole circuit onto this PCB like this. I connected a USB cable to power this circuit so that this circuit can be used with any other USB charger. I also soldered the LEDs onto a separate PCB board with some extendable wire. I have secured the wire joints and the bottom side of the PCBs with some insulation tape and hot glue to prevent it from rusting or any other damage. Now let's connect the USB to a USB adapter and fix this in our kitchen. I have fixed the device here just above our stove, and I have connected the USB adapter into the socket. As you can see, currently it's switched on. I have also connected the LEDs a little away from the circuit, pointing to the other room such that it's visible from there. To test the circuit, what I did was I switched on the gas stove for around 4 to 5 seconds and then switched it off. And after the next 4 seconds, I could see that the sensor switched on, the buzzer was making a sound and the LEDs were glowing. The buzzer was quite loud and could be heard in all the rooms of my house. If you are planning to make this, then please make sure you be extra careful while testing the circuit. Please do not test it directly near the gas stove. Use a gas lighter or a cigarette lighter to test it first. So that's all for today's video. If you like this video, you might like some of my other videos too. Please check them out at Electronics Made Easy, KHADER. Till then, I'll see you in my next video. Thank you.